so we are going to talk about our second transformation. We're going to be talking about a reflection. A reflection is a flip over a line called the line of reflection. Each point and its image, so our original point and the new image point, are the same distance from the line of reflection. So just think about, you can kind of see it over here in this example. B is 1, 2, 3 units away from the reflection line, and B prime is 3 units away. That will always be true. And if I fold along that reflection line, it should make a complete match. A reflection is an example of a rigid motion or a rigid transformation. Whenever we use the word rigid, it just kind of means that the shapes remain congruent. Their orientation may change, but it's still going to be a congruent shape. So the lines of reflection we're going to talk about, we're going to reflect over the x-axis, we're going to reflect over the y-axis, and there's a certain set of rules that we can kind of memorize for that. We're also going to reflect over vertical lines, so that could be like x equals a number will be a vertical line, x equals 4, x equals -2, or y equals a number, that would be a horizontal line. And we're going to do the diagonal lines of y equals x. So that means it has a slope of 1 and a y-intercept of 0. And y equals -x. And for those, honestly, we're going to learn some rules and some formulas that would be best to tackle those. All right, so essentially, I already graphed the original pre-image shapes for you guys, and now we're just going to follow whatever reflection they ask of us. In this case, we're going to reflect over the x-axis, so I'm reflecting over this axis here, and remembering that the points are going to be the same distance away, but on the other side. So if I look at A and I see A is 2 above the reflection line, I'm going to go 2 below, plot my point, and call it A prime. C is 1 above, so it's going to be 1 below, that's C prime. B is a little bit further away, so it's 1, 2, 3, 4, 5, 6, 7. So I can go 7 and plot B prime. Okay. And as we're writing these down, I want you guys to kind of look at the original pre-image points and the points that I'm going to write down. So A prime is now at -4, -2. So again, what do you notice is different between A and A prime? Let's look at B prime. B prime is at 4, -7. And C prime is at 5, -1. So if you're kind of looking at the original points and kind of comparing them to the new points here, hopefully you guys notice that the only thing that really changes is that the y-coordinates become the opposite. So our rule that we can technically say when we're reflecting over the x-axis only, I take my original points, and when I reflect across the x-axis, I take the opposite of whatever the y-coordinates are. The x-coordinate remains the same. Okay, let's do the same thing for the y-axis and kind of see how our rule compares. So I'm going to reflect over this line. Again, if you don't know the rules and you kind of don't need them, if P is 1 away, P prime is going to be 1 away on the other side. If Q is 2 away, Q prime is going to be 2 away. S prime should be about here. And R prime here. I'm just kind of taking in that mirror image, flipping it across that reflection line. Now let's look at our point. So now P is at -1, 2. Okay. Q prime is at -2, 5. R prime is at -8, 3. And S prime is at -7, 0. So again, kind of looking at the original, comparing it to what's new here. Hopefully you see that now it's all the x coordinates that become opposite. So those are the only things that changed, making my y-axis rule, my original points get mapped onto taking the opposite of x and keeping y. Okay. All right. That's fairly easy. For the next ones, it's just, again, being prepared where we're going to ask to reflect over different types of lines. Here, I'm asking to reflect over x equals 4. I know x equals 4 is a vertical line, so 1, 2, 3, 4. It's right here. So I'm going to reflect over that line. That's x equals 4. And there's no special rules here. I'm sure you can kind of add 4 or whatever. But sometimes it's just easier just to say, all right, L's 1 away, so L prime's going to be 1 away. J is 1, 2, 3. So I'm going to go 1, 2, 3 in the opposite direction. K is 1, 2. K prime's here. So that's just sometimes way easier to plot and see that flip and that reflection. And then let's just write down our coordinates. J is at 7, -1. L prime's at 5, -2. And K prime is at 6 and 3. Okay. All right, let's go to our next. So here we had a vertical line. Next we have y equals -5, which is a horizontal line, has a slope of 0. 1, 2, 3, 4, 5. So that would be this line right here. And again, I'm just going to reflect over that and do that fold. See how many units it's away and kind of travel along that path, but on the other side. And I'm not going to forget to label with my primes to identify that this is my new shape, right? Since they transformed, we're now going to write prime. So -6, -2 for M, -2, -2 for P prime, and -1, -4 for N prime. Okay? So very helpful to kind of draw that line of reflection, highlight it so you have that reference, thinking about folding it and double checking, is your shape still congruent? Is it the same shape, but just maybe flipped, different orientation? All right, the next ones are a little bit more interesting. Okay, so I'm going to do this, in a pencil, like a green pencil. So for the first one, it's y equals x. So that tells me it has a slope of 1 and a y-intercept of 0. So now I'm just kind of doing this diagonal, like kind of straight through, cutting through here. So if I draw this, this is the line I'm trying to reflect over, that diagonal line. For life's sake and just kind of keeping in mind things, you can count diagonals. It gets a little tricky. Where you can always do that, right? So like z's 1 away, so z prime would be down here. If you look at the rule, so z would now be at 1, -1. And if you kind of compare from the original to there, when we are reflecting across y equals x, the essential rule is that we are just going to switch our x and y coordinates, which essentially happened here. So if I'm going to do x, it's going to be -2, -5 for x prime. So let's plot that and see if it makes sense, right? So -2, 1, 2, 3, 4, 5, -5. Whoops, go back. She didn't go negative. Go negative. -2. 1, 2, 3, 4, 5. What's also good is you can check yourself visually because that didn't look right. This is like a diagonal and a half away from the reflection line. Makes sense with its relationship to x. And y prime, if we switch, it would be 4, -3. So that's 1, 2, 3, 4. 1, 2, 3. Y prime would be right there. So this I can kind of see definitely is that flip over the diagonal. All right. And very similarly on the next one, we have y equals -x. So same thing, but now I'm going down that negative path, right? So now I have a slope of -1 and a y-intercept of 0. So let's come back to, again, the rule. I believe that these are essentially very helpful. So when we reflect y equals -x, we do the same thing where we're going to switch the x and y, but to take into consideration the negative, we're going to do the -x and the negative of y and just flip. So it's -y, -x. So if I'm looking at A, I'm going to switch and make them negative, so I'm going to get -3, 1. All right, make 3 is now in the x-coordinate spot, and I take the opposite. -1, right? This is the x, this is the y. I switch them and make them both negative. So for B, it's going to be -6, 0. For C prime, it's going to be -5, -3. And for D prime, it's 2, 2. That one's kind of easier. I get the -2, -2. All right, so flip and take negative to kind of keep in, to understand that that's like that negative slope. I'll let you guys plot those points. Make sure it does look like it's reflected over. Make sure you plot the points correctly. Again, double checking visually is making sure if you fold across that line that you get a complete match with the corresponding points. And they should still remain rigid, which means they should remain congruent. All right, a glide reflection is just going to be one of our compositions we're going to talk about where we do more than one thing, more than one transformation. We kind of saw this in our intro Desmos activity where we did a combination of things. So the first thing we're going to do here, we're going to kind of do like an in-between step. This is kind of where that glide aspect comes in. And we're going to use our translation rule. And when I see this just tells me I'm going to go right 6. Because I know if I'm adding 6 to x, I'm moving to the right. Positive for the x-axis is moving to the right. And then y minus 8 means I'm going to go down 8, right? If I'm taking away from the y-axis goes up and down. But I'm subtracting, so that's going to be -8. So I'm going to take each of these points and move to the right 6 and down 8. So here we go. So 1, 2, 3, 4, 5, 6 and down 1, 2, 3, 4, 5, 6, 7, 8. That's going to be my in-between D, right? Like I'm doing 2 steps here. So I like to kind of sometimes cheat and recognize that G is like 2 diagonals down to the left. I'm going to move E 6 times to the right and down 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. I think I lost it, but that looks right. So that's E, and I know G is kind of 2 diagonals away, or excuse me, F is 2 diagonals away. So I got my shape here. That translation, it should be in the same orientation, facing the same way, just kind of that movement to the right and down. All right, now I'm going to take this in between, and I'm going to start with the green one, and now I'm reflecting across the y-axis. So I'm reflecting across the y-axis. So now I can just take my points and make sure, here we go, 1, 2, 3, 4, 1, 2, 3, 4, boom. D prime, E prime, I know is on the opposite side, and F prime is 2 diagonals away from that, so I can kind of cheat, and I have my new shape. Okay, so here you guys could have just used the rules and taken all the x and y coordinates, added 6, subtracted y, and then used my rule for the y-axis and just wrote down, you know, the final coordinates here. And sometimes that will be the case. Sometimes I'll just kind of ask you guys to do coordinate operations using the rules that we kind of talked about. Other times I will ask you to graph. And that's that with reflections. Nice job.